Hello everyone! Today with us we have Dr. Bettinger, a renowned professor of biomedical engineering and material science engineering from Carnegie Mellon University. Dr. Bettinger, would you like to tell us a bit more about your background and your research?
Sure. Yeah. First of all, thanks again, Karthik and Shanak. It's a pleasure to be here. It's a pleasure to be with you all listening in the future. So, yeah, I can just maybe share some slides to create a framework to maybe give some background to my career trajectory so far, and maybe a little bit more about how I see as the future of biomedical research unfolding in the near future. So, with that, let's go. So the title of my little vignette here is Navigating an Academic Career in Engineering, a case study. And so it's really aimed at high school students that might be interested in pursuing academic careers specifically, but more generally just engineering careers in general. And so um, I thought it'd be useful just to sort of maybe talk about my path in navigating this journey. So I am from Boston, but I ended up going to high school in Texas at the Texas Academy of Math and Science, which is like a 2-year program where it's like accelerated math and science classes, and you live actually at a university away from your home. So that was a unique experience. It kind of gave me an opportunity to think about college kind of before college, right? So you're charged with a lot of responsibility because your parents aren't there to tell you when to study or when to get ready for your homework and your science projects, things like that. So it's very independent, and so I think that was a great experience. And here I just for those who are listening, I just have some pictures of me just during my high school days. So I had some so I had a move-in day with my roommate, and we studied a lot as well. So we're kind of in this dorm, and we used to spend a lot of hours studying, and then we had some time for rest and relaxation as well. So there's me and my friends at our prom, just like you guys probably will go to in the near future. And so Texas Academy of Math and Science is we call it TAMS. So TAMS is this really cool feature that it's on a college campus, so you're interacting with professors at a pretty early stage. And so one of my most I would say enjoyable experiences was doing research in the summer before my senior year. And so I was lucky enough to link up with a professor there of biology, and there's this guy, Professor Kent Chapman, and he was basically studying like this cool plant biochemistry pathways to try to prevent flowers from wilting and fruit from going bad. So it's a really cool kind of dynamic. And so I spent a lot of time that summer digesting plants and extracting their seeds and looking at their chemical signatures on chromatography machines and things like that. And so eventually I actually ended up publishing or being an author on a paper as a high school student. So that's definitely atypical, right? But I think the take home here is that when you have opportunities like that, like where I mean, even just living in the United States is a tremendous opportunity. So I think it's important to take advantage of those opportunities when you can. And oftentimes, like me speaking with you, people in more advanced positions in their career are more than willing to help mentor young students along the way. So that's another maybe a little case study there. And so after that, I went to college at MIT. So I went back to Boston, kind of back home, and I majored in chemical engineering. We could talk about that. I stayed and did a PhD in material science and engineering an additional 5 years. And so if you look at that timeline, it's basically from 1999 to 2008, which sounds like a lot of school, but it's really the second part of that. It's really more like a job, right? So you're getting paid. You have tasks. You're exploring the frontiers of science. And so even though you are getting a degree, it's not like school in the way that you think it's school, right? It's significantly different, especially after the bachelor's degree. So after that, I made some good friends in graduate school as well. So really enjoyed my time there. So again, it's similar. MIT I think is similar to TAMS a lot in that it's focused sort of technologically driven, STEM focused kind of education, and very intense. And I think I kind of thrived in those kinds of environments. And so I had some good friends along the way as well. So then after that, I stayed in academics, and whereas a lot of my friends did not, but I stayed in academics and I did what's called a postdoctoral fellowship, right? So postdoc, right? After your doctoral degree. So in effect, you're doing, I mean, again, it looks like school, but really it's a job, right? You're getting paid, you have responsibilities, you do research. And I did that over at Stanford University. So I decided to get some warmer weather, so kind of closer to you guys. So yeah, so that was great. Bay Area is awesome. A lot of good friendships, but I was in a part of a big team doing lots of cool research and like building electronics that can bend and flex, unlike the materials in your phone, your laptops, which are like pretty rigid, right? So there's some interesting chemistry and physics that kind of underlie those kinds of devices and technology. And so after that, I basically was lucky enough to get hired as a professor at Carnegie Mellon back on the East Coast here. So this is just a map of me making my way back to Carnegie Mellon. So I'm actually in 2 departments there, which sounds cool, but it's not that different than just being in one department. And my departments are basically biomedical engineering. So the art and science of engineering technology to interface with biology, and then material science, which is basically the art and science of trying to understand materials properties at sort of their fundamental level. So and since then, again, in my role as professor at Carnegie Mellon, I basically have 3 main functions. I have a teaching responsibility. So I teach 1 class per semester, right? So basically like throughout a 9-month school year, I teach 2 classes, basically. It sounds like not a lot, but the classes are pretty intense and they can go in depth. And so that's one of my responsibilities, but what sort of eats up all the oxygen is actually my other responsibility, which is research, right? So I basically have my own little startup company where I hire in graduate students that are kind of like employees, and I have to raise money. So it's kind of like I'm raising venture capital funding. And my product, right, instead of being like an iPad or something like that, my product is scientific knowledge, right? But in many ways, the functions of my job as a professor in terms of research is like CEO of a research company in many ways. So in terms of, the skills that you have to be successful. And then lastly, I have my third sort of function is service. So I consider this service, like reaching out to students. I advise students on the Carnegie Mellon campus. I do outreach in Pittsburgh, right? I help the university with administrative functions as well. I review scientific papers to check for their veracity, right, and their correctness. And I organize conferences, things like that. So it's sort of like a catch-all category for other things I have to do as a professor. So those are the 3 things: teaching, research, service. And that's kind of what I wanted to share with you today. So again, so there's a picture of Carnegie Mellon there. I just talked about what I do. My research is on flexible electronics. And so I can just summarize that in just this one little visual vignette here. And it's essentially, the idea is, your body is flexible and dynamic and stretchy and wet, right? If you go inside of it, right? And the tissues are all moving around in weird ways. And they are communicating with each other, the tissues are, in very interesting ways, right? Usually by electric charge, right? So the idea basically is like, if you can like listen in and eavesdrop on what's happening, you can understand diseases, you can maybe even treat diseases. And that's compelling. But the problem is basically that electronics aren't designed for the body, right? They're rigid, stiff, planar, right? Not designed, like you can't really take a cell phone and like insert it into your body and expect anything good to happen. So how do you make electronics that are designed for cell phones and laptops, but how do you make them more designed for operating in the body? So that's a materials challenge, it's an engineering challenge, it's a technology challenge. And so we try to like navigate that complicated space. And so develop new technologies to interface with like the nervous system or the cardiac system or the gut, right? So there's lots of excitable tissues in the body that could benefit from sort of surveillance and intervention from these kinds of flexible electronic platforms. So that's kind of my little preamble that I wanted to share with you today. So I'm happy to pivot and answer your questions.
Thank you so much for presenting, and we'll move on to the Q&A segment of today's broadcast. So cool. My first question is, when did you first get interested in biomedical engineering? Was it all from TAMS, or was it before that?
Yeah, so my dad worked in like a medical device company, and so I like the idea of the impact of working in the medical field, just generally speaking. So it could be a physician, it could be like a device engineer, it could be someone that codes software for electronic medical records, right? There's all kinds of ways to make impact, but I feel like healthcare has like a particularly interesting impact because it's like literally a lot of times life and death, right? So that's kind of an interesting aspect to me. And then I'm more of like a spatial visual person, and so I like devices and like three-dimensional things, and I like chemistry. So it turns out like material science, ironically, is mostly chemistry and physics, but a lot of chemistry. And so just kind of triangulating like the like the vocation with the passion with the talent, and that kind of ended up being just focusing on biomedical engineering. So that was kind of like throughout your life, you'll have these little like inflection points where like, okay, that's interesting. And you can think about it like you're being nudged on a certain path, right? And so those are kind of like cumulative processes, right? It's not just like one day you wake up and like, I want to be a biomedical engineer. It's like you get kind of like insight from different parts of your life. You can kind of use that insight as information to kind of inform, your own decision-making processes.
So you talked about the people who nudge you into what you like to do. So the next question is, what has helped you to get where you are? And what advice would you give someone who wants to set off in a similar direction?
Yeah. I think so. If I sort of codify that question and say it's like, okay, if you want to be like a professor, or let's just say like an engineer, let's maybe keep it very broad. So I think one thing, it's like, these are easy to say and hard to do, right? So it's easy to say go out and find good mentors, right? That's the canonical advice. But like, what does a good mentor do? How do you find a good mentor? That's the tricky part, right? That's why not everybody does this. But finding a good mentor is very important, and that could be even just someone that's just a few years older than you, that knows a little more than you do, or maybe it's a friend of your parents, or an older brother, or a friend of your older brother or sister, right? So there's lots of like, ways you can be mentored, and I think it's having a network of mentors, right? So maybe someone's mentoring you on navigating high school successfully, maybe another one's mentoring you on how to get good at chemistry, and maybe another one's mentoring you on how to get into a good college, or so like mentorship is not always one-to-one. It's like you want like a network of mentors that you can kind of tap into, like a brain trust you can kind of tap into and say, I have a question about this. I'm going to go to my brother's friends and just text him like what's going on. So I think that's the super important thing.
So the second part of the second question here is like, what is the best resource for people who want to dive deeper, specifically in your subject?
YouTube.
Engineering.
YouTube. Seriously, just there's so much stuff there, and even it's like, or even Wikipedia. I know like teachers like hate Wikipedia. I don't know how that's evolved, but it's like start with YouTube, start with Wikipedia. Like don't end there, right? But start there, right? And especially if you're curious and you just find yourself poking around certain areas, or you find yourself gravitating towards certain things, right? So beyond just like Minecraft and Fortnite, right? If you're going to actual like interesting like scientific domains, if you find yourself gravitating to one thing or the other, I think so. It's interesting. It's like one thing is like, okay, like there's an infinite amount of information at everybody's fingertips, right? So access is not really the problem anymore, right? Like when I was a kid, it was access. It's like how do you get the next like Wired magazine? Like so you have to go to the library, and it's like it's a huge pain. There's a lot of friction, right? But now it's like it's almost the opposite. It's like you have all this stuff. How do you filter it? How do you process it and manage it to make it tractable? And to me, that's a much more challenging question, right? Because it's like, again, back in my day, it's like, here's the journal. That's all you had. You just read the journal from cover to cover, and that's it, right? But obviously you have access to every journal that ever existed. It's like, you can't just do that anymore. So I think you have to like filter and overlay your interests with like maybe societal needs. I think that's a good way to think about it. So see where those things intersect, and then just Google that, right? And then you're probably off to a good start.
So this question's a bit unrelated to the previous one, but what do you think the future of the biomedical industry, and what do you think the future holds for us based off of those technologies?
Yeah. So I think a good example is like it's not the best, but it's a very observable, it's a very popular example, is like Elon Musk's Neuralink. So if you guys have heard of that, basically it's like this brain, recording device that can like eavesdrop on the brain and use those signals, that information to control like a robot, right? So that's like the typical answer that you'd hear, but I'm maybe that. So maybe something else. I don't know, but like I think in general, like I think one thing that's interesting is like I think there's so much. I mean, there's so much to be learned just with like genetics, just like basic. Nah, it's not basic, but it's like like there's a lot to uncover with genetics where you can go from like discovery to like technology to like impacting human disease in a good way, like very quickly, right?
So, you mentioned about how you got into a paper as a high schooler, which first of all is very impressive. But how can high schoolers like you at the time get into published journals and get into these really impressive and amazing papers at such a young age?
Right. I mean, so I think it's atypical. So I don't think that's an expectation, right? But how would you do it? I would say, like unfortunately or fortunately, it seems like connections, right? So it's always like the son of like rock star CEO that knows the professor at Stanford, then gets their son to the Stanford or their daughter to the Stanford or something like that, right? So I'm not a huge fan of that kind of nepotism, right? But that is, again, it's kind of that network thing, right? So that's one way. But like I would say like whenever like just general advice, like whenever you want something, right, from someone, like make sure you're bringing something to the table, right? So I would say bring something to the table. If you haven't asked, right, you're asking for something, like make sure you bring something to the table. Maybe it's like, hey, I'm willing to wash like test tubes for like 2 weeks. I just want to be around the lab and just like talk to your students or something like that. So just like have like a concrete like plan or something to offer, right? Just to distinguish yourself from like the sea of other people that want to do the same thing as you. That's I would say that's advice that I still heed to this day. If I'm asking someone for something, I bring something to the table, right? I'm not just asking for just, for nothing, right?
So here's another question about high school. So what was your high school experience in general? Can you tell us more about what you did in high school and how was school in general?
Yeah, so I had kind of like two phases. One was like I was at this like sort of like normal public school in Texas, and that was like this big 3,000 person high school. I was on the soccer team. I was on like the math and science team, and I was on like this kind of like on these like nerdy like clubs, which I actually really liked. But I also had soccer as well, so this athletic pursuit on the side. And then that's freshman, sophomore. Then junior, senior, I was in this TAMS thing, and so that was very different, right? So that was like a mini college student. So I was in a dorm. It was a big cafeteria. Wake up whenever I wanted, not whenever, but whenever class started, right? And then it's like class is over and it's like noon, and then you're like, okay, like I'll just like study like the rest of the day, or go out with friends at night, stuff like that. So it's two very different experiences. One is more classic high school, I would say, like American high school, and the other one is almost like pseudo college. It actually was like college in many ways. So but in that second thing, we did prom, we did homecoming and stuff like that. So we had sort of like these normal experiences. But I really didn't like the first one that much. That's why I went to the other one. So yeah, I didn't like like the bell rings and so everybody's like marches off to their next class and the bell rings again. Like that wasn't my style. I didn't like that. But I've seen people once they get the freedom of the college, it's like they kind of just like they blow it. They just like don't study or they procrastinate, and then that's bad too. So yeah, I think as you go through life, being independent and successful and competence, those are very important things to do. So
I think our final question for you today is what are some life tips that you've learned throughout your life and throughout your career?
I think it's like, for me, so I also climb mountains and I go skiing, and I like being out in the cold and camping in the snow and stuff like this. And so I think there's like a symmetry with mountaineering, which is like being comfortable with discomfort, right? So like not every phase of your life is going to be this comfortable experience. And in fact, if that's the case, it probably means you're not pushing yourself hard enough, right? So if you think about like an athletic pursuit, like you have to train, it's practice is hard, right? If you think about an intellectual pursuit, maybe it's like reading a book, and it's like the book is very dense and it's hard to like get through everything. And so I think it's just appreciating and understanding that like it's not comfortable, but that's okay, right? It's okay to be uncomfortable. And so the analog to mountaineering is like you're trudging up some like snowy cliff, and it's like your feet are frozen, and it's like the wind's buffeting your face, and you can't see, and it's like you don't know where you are. It's like, yeah, that's like a really kind of a challenging situation, but you just kind of like reset. You're like, okay, like I'm here. This is challenging. That's okay. Like, what do I do next, right? And so I think there's a lot of lessons that you can kind of bring from that. So yeah, so maybe I'll leave it there.
Okay, great. Yeah. Well, everyone, yeah, thank you so much for watching our session with Dr. Christopher Bettinger. Yeah, and take care, and we'll see you all next time. Bye.
Cool. Thanks.